Question is focused on digestion. It tells us in the question that we've got two biological molecules. We're talking about starch and a dipeptide. So in our heads, we need to think about what structure these molecules are going to have. So starch is a polymer, whereas a dipeptide is going to be two amino acids joined together. If we think about the enzymes that are going to need it to digest or hydrolyze these bonds, then we're thinking about what's going to be which enzyme is used first in starch digestion. So we think about the acronym SAM-PAM-MEG for digestion. Starting with SAM, salivary amylase will break down or hydrolyze starch into maltose. That's the first enzyme that starch is going to come across. And as we said, it hydrolyzes the glycosidic bond in the middle. So therefore, it would break that green dot, ending up with two molecules of maltose. So when we're thinking about the enzyme, we're thinking of amylase. When we're thinking about the bond, we should know it's glycosidic, and then we've got the product of maltose. If we weren't sure whether it was maltase, well, that's kind of ruled out maltase because maltase would hydrolyze maltose into individual glucoses. If we think of our dipeptide now, then we're talking about a protein. Proteins are held together by peptide bonds. And if we're hydrolyzing that peptide bond, what are we going to be releasing? So if I hydrolyze the bond in the middle, what we would get are two individual amino acids. So in terms of filling in the row, we want the bond being peptide, and we want the product being amino acids. This is a recall question. There's nothing that's challenging about this question. It told the examiner or your teacher whether you'd revised or not, whether you'd gone back to the beginning of year one and actually looked at that biomolecules topics about carbs, lipids, proteins, digestion, enzymes, all that first stuff. So it was a very generous 4 marks, 1 mark for each of the blank areas in the box. We then got, moving on, the investigated starch digestion by mixing starch with a solution of an enzyme. The student did a biochemical test for protein when starch digestion was completed. So they wanted to know, how do I know if there was a protein present in my little beaker? Again, another recall question, another question that should be straightforward. We either knew the answer or we didn't. How do we test for a protein? Biuret or add biuret, or if you really want to, you can say add copper sulfate and sodium hydroxide. I don't know why you would make it more complicated. A positive result would be the colour purple. You're accepting lilac, violet, mauve for purple. If you'd mentioned anywhere in your question about heating, that rejected mark point 1. So if for some reason you've got mixed up with a Biuret test and a Benedict's test, then unfortunately you're going to lose the first mark point if you mention heating. This was a test for a protein. A Benedict's test would be for a reducing sugar. Why was the test positive then? So why at the end, because it clearly tells you in the question that they're doing it at the end, would we get a positive result? And when we did this and marked this, what we were seeing is lots of students getting mark point 1. You've made the connection that an enzyme is a protein. Brill. However, this question was worth 2 marks, so we needed to elaborate a little bit more. Essentially, why at the end of the test will the student get a positive result for this protein? Well, yes, an enzyme is a protein, but enzymes don't get used up. It'll be still present and therefore would give you this positive result. Quite a lot of people were missing that last mark point 2. And then moving on to this final maths question, an enzyme its turnover number, kcat, is the number of substrate molecules converted into the product by one enzyme molecule in 1 second. It is determined by using the equation. I have no idea what this equation is. The information that we're going to use is actually there on the piece of paper. So it tells us that the student investigated the action of protease. The scientist prepared a reaction mixture with protease concentration of 0.0118 micromoles per decimeter cubed. So that is the enzyme concentration. So I'm linking that to the bottom of my equation. It then tells us the kcat for protease was 110. And what I would like to work out is what's the maximum rate of the enzyme controlled reaction. So I'm working out the top part of my equation. And most importantly, use the information for the formula to calculate the maximum rate of protease controlled reaction. Give your answer to 3 significant figures. If we don't do that, it's going to cost us marks. So we're going to rearrange our equation. Thinking back to GCSE physics, let's think about how we're going to work this out. So if I give each of these parts a letter, so we say A, B, and C. To be able to work out A, I have done C divided by B. So therefore my triangle might look a little bit like this. But I don't want to work out A anymore. I need C to be the focus of my question, or focus my calculation. Therefore I need to rearrange this. So to be able to work out the maximum rate, I'm going to do C equals A times B. And in this equation, that would have been 110 times 0.0118, giving me an answer of 1.298. However, that's not 3 significant figures. So as 3 significant figures, they would like an answer of 1.30. Lots of people missed out because of the fact that they didn't put it to 3 significant figures.